Morning viewer, welcome to our FTV viewers. A new study tracking thousands of B cells across more than 100 germinal centers in mice reveals how the system consistently produces highly effective antibodies. The findings overturn long-standing ideas about how germinal centers function, revealing that they are far more selective than once thought, and challenges the idea that antibody improvement is driven mainly by rare growth bursts among the most successful B cells. The findings are published in the journal Cell. Viewers, the discovery could have implications for immune cell evolution and ultimately guide the design of vaccines against rapidly mutating pathogens like influenza. It also could lead to new ways of studying evolution itself too. Viewers, the traditional mechanistic view of germinal centers is to think of them as selection machine sorting out the best antibodies, says Gabriel De Victora, head of the Laboratory of Lymphocyte Dynamics at Rockefeller. But when you look very closely, you see a process that almost essentially random, a bit better than a coin toss, which repeats many times until the immune system arrives at the right answer consistently. That's much more akin to how evolution operates than the way a machine does. Inside germinal centers, B cells rapidly mutate and compete to produce antibodies that bind successfully better to pathogen. And that puts B cells under intense pressure to optimize a single trait binding affinity or how well an antibody recognizes its largest. But how? But how they accomplish that feat has a very much remained an open question, because weak and strong B cells often coexist side by side in the germinal center. So scientists now have long wondered whether the immune system temporarily preserves weaker cells in case they later acquire useful mutation. The phenomenon of clonal burst, in which the descendants of a single B cells rapidly take over an entire germinal center, is also poorly understood even now. Behind this exclusive report.